so let's just jump straight into it. So Roberto and I have a collaboration which has been going now we met a little bit before we started at Hong Kong Baptist University, where we both work, which puts us back to something like early 2019. We've been kicking a ball back and forth between myself, my background is as a painter, and then working in computer graphics. Roberto as how would you describe yourself?
Nowadays, I don't know. I used to be a musician back in the days. Nowadays, it's kind of difficult.
A headless chicken was the last description. That's right. I heard.
Mike the chicken, yeah?
I would describe you as a musician.
Without a head for 18 months, that's me.
A musician who also knows how to turn things on, something like that.
There you go.
That could be read the wrong way. Right, so there's a few projects we're going to run through, which I think for a lot of artists is how we learn how to do things, how we build technological solutions that we didn't know we needed, is coming up with an idea for a project and then realizing it has a lot of holes in it, and filling those holes is sort of, or filling these gaps, I think has led to, I guess, the knowledge base that our collaboration has.
Yeah, so I think, I mean, the question that Peter was raising about, what do I do, who am I, has to do with the fact that we do a bunch of different things. And that includes electronics, developing electronics, sensors and so on, software development, artistic practice at different levels. So we move beyond these different domains, and that's part of the reason why we have all of this experience related to multimodal mapping, because all of these different parts involve a kind of know-how that allows us to connect things and to explore connections and so on. Yeah.
Yeah. So let's. This is. There's quite a few friends in the audience, so some of you probably know some of these works. This is a short creative reel of some of our performances, and what we've just added in a few little descriptions of some of the techniques we're using. In the creative projects, we're going to go through some of these projects, give them a short introduction, and then towards the end of the presentation, we're going to discuss some of the technological tools that we've developed over the course of making these projects. Okay, so we'll go through these projects chronologically, basically because with each project we do, like any logical person, I think we often reuse approaches we develop in one project and then we sort of build on it and improve it in the other. So maybe Roberto, you're the musician.
Yeah, this is a project from 2022. Later we'll explain what we use here. Mainly we're embedding sensors into traditional musical instruments. This is one of the projects we developed where the sensors are embedded into a violin bow. There's actually, if you fancy reading some research, there's an article coming out next month on Computer Music Journal, and it's a special issue, and this is going to be kind of the main article discussing how we embedded sensors into a violin bow without modifying the structure of the bow. So the idea here was quite simple. We have classical music people out there. They've been trying to learn to play this instrument for 20 years, and they want to keep playing it. If you modify it, they are not going to use your tool. So we've embedded these sensors into a bow that is exactly the same, and then we talked to this string quartet, European string quartet, Asisa, of some really amazing players that are now working in different places. She's the concertmaster of the Spanish National Orchestra. She's a professor in German at Hochschule, really great players, to perform Shostakovich quartet with the bows. And we developed in Dutch designer a patch that mapped the movement to some really interesting, we believe, visuals. We tried to make something meaningful and nice. And we invited them to test the bows, perform with them, and that was mainly the project. So what you can see here is them using the bows with embedded technology, and then on the screen you have real-time visualization of their movements.
Yeah, and it's funny that John showed Alon Ilsar's drum project, because we know Alon through a completely separate mechanism. A friend of mine who runs a record label, when we were telling him about this idea of trying to put the sensors inside the violin bow, he's like, oh, you've got to talk to my friend Alon. He's been trying to do that with drumsticks for years. And we had this very funny conversation with Alon where he said, don't make hardware devices. It will drive you crazy, but it's also really fun, which is exactly, I think, the situation we've been in.
I mean, I think some of the early questions that we had with this project that we still have, and we'll discuss that later, what types of data do you use? Where do you get your data from? And using sensors in general is a noisy environment. So there's a lot of cleaning that has to be done, sensor fusion in this case, learning what the best approach to visualize something might be, and thinking about variables. So this was an early experiment at filtering some of that, making something meaningful out of it, learning how to relate it to the data, how to clean it, how to,
And also with a really, from my perspective, I'm not a musician, a really odd fixed outcome, that it's a Shostakovich piece, it's in a genre of music with performance conventions. So we had creative problems of what should the graphics look like. We had to reach out to a bunch of people to help kind of augment our ideas to something that made sense and worked. And then, as Roberto was saying, the reason we've made this little GIF of what our OSC inputs are is, there's always this tug of war of some of the raw data coming out of a sensor can be really useful in one domain and completely useless in another, just depending on the types of movements people are doing. And then we get into the complexity of processing that data into things like linear acceleration or quaternion rotations that have their own issues. So these things, it leads to, for us, quite a fun back and forth of being very specific in what motion we can grab, and we love the idea that the sensor is tiny and hidden, but then what we do with it. And with all of these streams, trying to find the one that matches what we're trying to express, which is completely an artistic problem. It's not a technological problem, but the bridge is this sort of trying to build the right logical connection, which in a way is sort of what inspired us to design the workshop and performance series in this way. It's trying to do
this later we'll explore that this led to questioning the actual mechanics of the elements themselves. What is an accelerometer? How does it work? What type are we going to be using? Because we developed our own board with our own kind of combination of elements. So understanding how the data is being generated is also important. Otherwise, it's just floating numbers that have some sort of meaning. So looking at the mechanics of the sensors themselves was quite relevant as well. Yeah.
And we did some tests with the quartet in things that are more common with demonstrations of IMUs is, like a rotating cube. And so twist on that was to replace the 3D model of the cube with the 3D model of a violin bow. And even here, it's pretty good, but it's also quite noisy. So there would be a degree of how much do we filter, how much do we smooth the data, how much latency does that introduce, and what's the sweet spot between that? And then what's the range of motion where that mapping starts to not work so well? And then you get into the strange limitations of the sensors themselves, that if you rotate something a full 180 degrees, the quality of that data outside that range might not be as good as it was within that sort of sweet spot. So these things were kind of interesting to work with a bunch of musicians so they could see exactly what this sensor was doing. But then in the performance, it didn't really make sense. It made more sense to sort of work with graphics in a more abstract way.
Yep.
Okay, I'll go to the next one. So this is a project that we started in the middle of COVID, and when I guess like everybody working creatively, the projects you made during COVID all have a different spin on them because everything you did was sort of defined by it, from how you rehearsed, how you performed.
Well, I mean, this performance down here, that's me after 21 days of quarantine, coming out direct into the rehearsal and then recording until 5 a.m. So
I think actually
my brain there was...
in the video that's in the next slide, we see that and you look like
I
you're
look great. Okay.
kind of dead. This was a project we did. Some of you would know Sudi Liao. She's a dancer, was based in Hong Kong for quite some time. She's in Singapore at the moment. We worked with Sudi quite a lot on and off. And in this performance, this really started as something we were doing at nighttime or on the weekends, originally with an Xbox Kinect of like me playing around in graphics, you and Sudi performing together and us seeing what sort of fun we could have by mapping those things together. And then at one point, as universities tend to do, university was looking for a project to expand, and so we offered them this. And we got to take it to a higher degree of complexity by looking at generated motion using a motion capture suite and AI-generated motion. So this is a quick short of that, and I think you do get to see Roberto looking like he's been in a hotel for 3 weeks.
My name is Sudi Liao. I'm a choreographer and movement artist from Singapore, currently based in Hong Kong. My project Capture and Release will examine the epistemology of motion capture and the cultural locatedness of technologically augmented performance. In 2021, Roberto Alonso, Peter Nelson and I began developing Descendant, a piece for dance, violin, motion capture and AI-generated motion. Using a musical, choreographic and visual interpretation of the Promethean myth, Descendant became a live performance for exploring gesture, communication and agency. It also introduced important questions concerning how we record, categorize and access motion data, especially in the age of generative machine learning models. We created a dataset of my own dance practice coded with Laban notation and paired to phrasings in classical violin. The result was a system that could visualize my own motion as well as that of an AI-generated avatar moving in response to live violin performance. Using an interpretation of Mary Shelley's Frankenstein and the Prometheus saga, Descendant explored questions of knowledge systems, procreation and identity via interdisciplinary and cross-cultural collaboration. Descendant provided me with the ability to dance with an AI version of myself, but also raises questions concerning how datasets are defined and what knowledge systems are used to train AI models. In recent performances, we have experimented with DIY wearable technologies, as well as remixing fragments from critical debates surrounding technology and access into the performance itself.
Okay, so that project, I think the things that we probably, some of the trickier mapping questions on my side were, if anybody here works in graphics, probably some simple things like, parenting rigs to skeletons, the generated motion, often when used for testing, is used on a robot rig. Often half of the limbs are facing backwards, people don't notice. There was stuff there, but I think some of the more interesting questions were what you and Sudi had to do in mapping motion to music through Lubber notation. Like as Sudi was talking about, the data set itself, in how do you, to make a training data set, maybe you can talk about how the hell do you make like a tagged data set of these two domains.
This project has been discussed on a book that was published in January 2024 called Choreomata. There are 2 chapters there that discuss this project from 2 different perspectives. Key complexity of the project is a mapping mechanism that translates. Ideally, it was planned to be in a kind of 2-directional way, mocap data from dance that has been organized into something where gestures have some sort of meaning using a Laban approach into sound features. So the idea that you have sound going into the system, you analyze sound in real time, and then translate that into chains of mocap data that would be like a, an AI version of the dancer. The idea that you also do the opposite, you have real-time mocap data going into the system, and then you should be able to generate sounds that would be the natural pair to that mocap data. We only explored, I think, the first part. The second part was never fully explored, but that's the idea. It's a translation between a semantic space that has to do with dance and then one that is music.
And thinking back, one interesting gap that we sort of found was that because there's plenty of work done in this space to make computer-generated motion that can dance to music, because it's super valuable, has a huge commercial application. And I think almost all of it was just mapped to beat recognition. Wasn't that basically the space that...
Rhythm.
Onset?
Yeah, onsets, yeah.
Difference being...
No, it's the same. Yeah,
same thing. Okay. So what we found in like the existing training data sets there was this artistic gap that dancing, especially as soon as you look at contemporary dance, it's not dancing to a beat. So none of this made any sense. So this sort of process that Roberto and Sudi went through of a musician and a dancer who've worked together enough that you've played, and Sudi will sort of choreograph motion to that. There was something implicit that you had to make explicit. And that was a kind of an unexpected challenge in mapping that I think made a really nice contribution of like, okay, there's this system of Lubber notation. You can make it a tagged data set that is something more than a generated motion kind of bopping along to a beat in various styles.
Yeah. So the state of the art at the time was mainly to do with like, I think like rap music or like pop music that had really clear rhythmic structures, and it was based mainly on onset detection. So it had to do with the rhythm of the music. And the question in this project that we kind of have developed with the computer science team from the university was, can we think differently from a kind of spectral, more complex, more holistic perspective? So that it's not about dancing jazz or dancing, this type of hip hop or that or the other thing. It's a bit more kind of open question where you can fit completely experimental music into the system and still get dance that is meaningful.
Well, I think so one thing Sudi was talking about there was like ethical or aesthetic questions in how data sets are recorded and tagged, that the assumption that dance is simply like matching your movement to a beat is incredibly reductive. And so going into some of these processes and questioning, well, that's it? That's all that dance is? That was, I think, a really nice outcome of saying, obviously, you talk to a dancer, that is a huge reduction. And so therefore, if the entire model is based on that assumption, then the results are going to be as limited as the assumption.
Yeah. So, I mean, as you may assume, part of what we had to do here was come up, because that was the approach, it was a conditional kind of approach, was to come up with labels to define different types of music or dance. And that part of that was a fight with the computer scientists when they would come to you and say, okay, give me happy and sad music label. And you're like, it's a bit too simple, yes. We might have to find labels that are a bit more meaningful and that relate in a more interesting way to the musical content.
And the same with dance.
So part of what we had to do was come up with a labeling system that was a bit more comprehensive than the standard and a bit more meaningful for us as artists, so that the mappings would be more interesting.
Yeah. I'll skip ahead.
Yeah.
So this is moving a bit ahead, but it's partly because a lot of projects we work on, by the time they get to exhibition, some part of them has been in process for a while. So they overlap, which I guess is normal for anybody who makes anything. So this is a shot from one of the classrooms at BU, but it's using some of the bridging software that Roberto and I had developed, which in this case is simply to connect IMU development board to some of the robotic arms that we've been teaching with the Baptist University. And this, bits and pieces of these bridges have been developed across two projects. One of them, our work with the violin bow, which was a bridge to send OSC data low latent through a Bluetooth low energy, low latency bridging app. And then the second one is to, we're bridging through Touch Designer, taking that OSC data in, and then using a second bridging app that's been put together by a colleague and friend of ours, Daniel Stempfer, which then sends an OSC message to the robotic arm as positional data. This is the first version we had, which was just sending basically the position of the end of the robot. Now we have one that can do far more degrees of freedom of movement. But the goal in this, again, is to map one domain into another, which will eventually be a robot that can either paint or play an instrument and so on. But in just getting to here, it had a whole bunch of little, not only sort of plugs that we had to develop, but working out which piece of data would logically make a logical translation into which actuation. Roberto, do you want to add anything onto this?
So, if you are not busy on June 12th,
oh, good call.
You may as well witness this in real time, hopefully. It will. And we have a performance on June 12th at the Visualization Research Center at HKBU, where we're going to be doing real-time distributed data transmission to control both sound, DSP, the robot arm, and a bunch of other things. And it's going to be a really cool performance where the robot will be placed inside this unique new cinematic space developed by Jeffrey, who was here earlier. And we're going to be doing, I think, really interesting things. We'll have 3 performances, so if you want to join, we'll share details. It's going to be like 15 minutes each, something like that. We just walk into the space. The performance lasts 15 minutes, and then we have some snacks, and we can talk and discuss that.
Yeah, I described this performance. Its motivation is sort of, we had this project. It's another COVID project where we wanted to do research. At that time, we described it as remote collaboration, development of small applications for remote collaboration, because that's what everybody was doing in COVID, and Hong Kong had a funny head start on that we seemed to start COVID earlier than everybody and finish it later than everybody. So this type of research, there was a huge call for it, and so that's why we were able to get some funding to do it. But what it ended out as being was a whole bunch of these small bridging systems that can just allow, the OSC bridge that we had to not just simply be a local solution, but be an international online solution. So looking at who has made protocols for sending that same type of signal, low latency, online, and then bundling that into some of the other bridging software that we've made. So the performance has this sort of, can we get this to work quality to it, which we hope doesn't crush the aesthetic quality of it. But I think in some works, this is, it's really like a, can we turn everything on at once and see if it all works? Because then after that, we'll understand the utility of all these components. And I think it's a real, like a stress test for them, is how I describe it.
Doing something like this might seem easy. I mean, it's been done in the past and stuff. But a movement as simple as moving a bow over a string and making sound that has good quality it's a great challenge for robot, because the amount of complexity that goes at weight level into controlling how sound is being produced is quite interesting. Different variables. So we've been testing this for a while. And Daniel, the other day, he was telling me, you know, the robot is not so good with superhuman movements, which is what you do when you play. So we're trying to fine-tune that, but there is a complexity to interacting with a string that as soon as you modify a parameter by a 1%, the sound breaks. And that's why, you know, when you listen to a young kid playing the violin, it's usually not very...
Yeah, and there's incredible things you learn about, like the inertia of movement, that as Roberto bows a string, the acceleration, deceleration, and the release of the string, the complexity of trying to replicate that forces us to improve every protocol we have for using a piece of equipment. So there's a sort of, I'd say some of these projects are designing something that's deliberately a little impractical but fun, but in doing so the capability of how to use these things we think improves reasonably well. So this is the last part of the talk. We'll probably just go for another like
short. Yep.
5 or 6 minutes. Just on the sensors, that after a while, after using some development boards, it seemed logical in our own spare time to make some sensors of our own. And Roberto's really been leading the charge on this, so.
Yes, so we use some of the solutions. I guess if any of you have used IMUs in the past, you probably dislike them, which is perfectly fine. I think the idea with sensors here is, I mean, for you to understand that we've used not only IMUs, we've used, you know, cameras to extract data. We have a bunch of sensors at the university, ECG, EEG, and so on, that was also used. We use a lot of sound features that are extracted in real time. We developed a tool last year that, you know, is a comprehensive implementation of the Sensia library, where you can extract so many different things. But the focus on the IMU had to do with some of the projects we were developing and the issues that we found with the boards that you have out there. What is unique about this board is size, which is 21 millimeters by 13, 5 layers, BLE connectivity, and what makes it a bit more interesting is that there are not many boards, well, there's no board at this size that incorporates this little guy here, which is a really cool piece of, it's a really cool chip because it does compute sensor fusion in the board. So these board outputs already like quaternions that are really clean, as well as raw data, and that allows us to work directly with the pre-computed, let's put it that way, data, but also to modify sensor fusion if we want on the end device. So we've been working on this for a while. It has a microphone, different questions, how to integrate. We were trying to integrate, and we have integrated raw data, like IMU sensor data and audio into a single Bluetooth characteristic to simplify the process where we decodify all of that and latency becomes a bit smaller. How to codify, you know, the codec for the audio and so on to maintain the quality. So a bunch of different questions that have been answered. Another important aspect of what we do, we were showing it before, and this is just for the IMU, but this is a more kind of general question for everyone. Data. What types of data are we using? Why? To what extent is the data that we use relevant? And how we map it? Yes, the idea is that in principle you can map anything to anything, but then, you know, that's not something that is maybe truly interesting from an artistic point of view. So what are you going to map? What type of data are you using? How are you extracting it? And so on seems to be really important for the kind of work that we've been trying to do. Yeah. So data is a big question. It seems like a given, like a scientific, you know, extraction of elements from sensors and so on, but understanding the data, cleaning it, is really important.
Yeah. And the one thing I'd add to that I hope that over these seminars we can tease out a little bit, and it was partly the motivation of my question to John, which was, I have really mixed feelings on things like data visualization or data-based work, data-based artwork, or something where the interaction is either unclear or incredibly clear. And to me, I have my feelings about these, but I'm not attached to them. But for example, a data visualization where if you swapped out one set of information for another and people couldn't tell the difference, or it just looked like another form of abstraction, is that a less successful artwork, or is it simply okay that what you made is beautiful and that people can kind of appreciate the presence of this information? Or does the visualizing of data have some obligation in terms of communication in the way that a graph or a chart might do? And artwork is not a graph, so to what degree, and this I think is an open question, but one that I'm quite interested in, to what degree is the communication through the mapping important for the artist and for the audience? And I'd put the same on interactivity, that my bias is towards things like computer games where I think part of the fun of interactivity is knowing what your relationship to this system is, knowing what the button does or something like that. However, like I totally can see the virtue in John's answer, that if the system is sort of recording an interaction that doesn't require this prior knowledge, then there's an absolute value in that approach, but to me they're sort of different. So this question of like whether the mapping, to what degree the mapping communicates or doesn't, is one also that I hope over these seminars and then in the works that start getting made in the second half of this program, I would love to sort of build up a base of knowledge and opinions on these type of questions.
And I think that's both an artistic and kind of aesthetic decision. But we are aware of the fact, we've been working on, lately a lot on Touch Designer, where we have a switch. So, where we have two versions of the same patch, and the switch is just going to change between pre-generated noise and real data. If you're using the noise and you're not realizing, like you forgot to switch on so that you use the proper data, then something it's not working there. So we're usually trying to be honest on that sense, avoiding noise as a kind of starting point and trying to find connections that are meaningful. Yeah.
Okay, and then the last part on the use of bridging tools. These are things that I think Roberto has really been incredible at identifying gaps and solving them. So Roberto, you can go through.
Yes, we've developed the question is how to get data from sensors and transform it into something relevant. OSC is a protocol that is commonly used nowadays. It's quite useful, quite powerful. There are others, but we chose OSC as the way to connect Bluetooth devices to our computer and then send out data in a clean, low latency approach. And what we did as well is we implemented something that was developed originally in Canada by Michael Palombo that is called All Hands, which is an OSC over the internet low latency transmission mechanism. So what we have now...
Is that on the video? Do you want me to
it's on the next one, yeah.
Okay, yeah.
What we have now...
That's a video, is that?
Yes.
Yeah, okay, cool.
Is this where you can connect a device and immediately send data to the cloud with low latency so that anyone else in the world can get that data in real time with really low latency. It's not zero, but it's low enough for it to be something that you can use in a kind of meaningful way. So here we connect the device, we select incoming, outgoing, we tell it to display the data, and then data streaming. If you join this same app elsewhere and you use the password that I put in there, you have access to my data in real time. So that's something that we're going to demonstrate on June 12th, where we will have someone outside of the space controlling with a sensor something that is happening in the space in real time. That's part of the idea.
And I think it's a funny world that we're like a generation after telemetry being really difficult. There's important works in the history of media art of setting up a live video stream between two places, and we live in the age of video calls and Zoom and so on. But there's some perverse pleasure that we find in being able to do that with things that aren't like audio and sound and vision. So I think that's also part of the fascination, is that this little sensor, stick it in your pocket, stick it in a musical instrument, blue tack it to the bottom of a table, and all of a sudden you're having that same telemetry experience just with a data format that's not the one that's super easy, but gives a huge amount of flexibility. And one type of motion can become the type of motion for a robot or the type of motion on a screen and so on.
Yeah, so this is a taster of the space where we're going to be performing on June 12th. I think some of you, I know Torin knows the space, and I guess Brian as well. This is high-speed version of a performance we did 2 weeks ago. That's in the space, and with the bow here, I'm controlling sound and lights. There is no sound because I had to accelerate the whole thing, but each time that I do something with the bow, something is happening, audio reactive visuals, and so on. It's a really amazing space, and it's a pleasure to work in there. It's a bit overwhelming, but that's what happens when you're surrounded by screens.